everyone. And yes, sorry, I don't have pink hair anymore. I have blue. I changed it on you. So yes, I am Jenn Creighton. I work at Netflix as a senior software engineer. I am active on Twitter if you want to shout out to me there or DM me or talk to me at any time. Would love that. My handle is girlcode, girl with a U. Okay, so as you know, this talk is focused on debugging async JavaScript. And there are various focus areas of this talk. Much like asynchronous code, we aren't going to go in order, but we are going to hit on these topics. So why is debugging asynchronous code difficult? I think there are some particularly tricky reasons for that. We're going to talk about what common pitfalls we can avoid when writing async code, right? Helps us avoid bugs in the first place. And then what are some debugging options when something's gone wrong? How can we figure out the problem? Now, to kickstart these topics today, I am going to be showing you some examples of async bugs. And if I show you the code and you don't know what the bug is, that is totally okay. This is absolutely not a quiz. But some of you are going to know. Some of you are going to know right away what the bug is and why it's happening. And if that happens to you, I want you to do something for me. I want you to ask yourself, how do I know that? Not why is this bug happening, but how do I know that? And I'm going to come back to this, I promise. So moving on, let's get started looking at some code. Now, in this scenario, we are tasked with retrieving a config file and validating a property on that file. And our coworker lets us know that there's a function we can pull in to retrieve the config. So that's what we do, okay? We import the getConfig function. We call the function expecting it to return the config. Okay, except it doesn't, of course. We get undefined. And we don't know what's happening here, and we're going to have to look inside of the getConfig function to find out because, no, there is no documentation. Okay, here is what we discover. getConfig takes a function. It's going to read the config file. And then it's going to retrieve back some data, which is the config file. And then it's going to call that function with that data, okay? So this really does not work how we expected. And to be honest, for our use case in this example, it kind of sucks to be passing in a function. Maybe, though, we could modify this to return the config. So let's do that. Let's create a new variable to hold the config. We're going to assign the data to that config. And then we're going to return this. And of course, when we run this, we get undefined. Okay, we still get undefined. This example is loosely based on something that happened to me a few months ago, and I have changed several of the facts. But I did need to use a function that retrieved a config, and when I ran it the first time, I did get undefined. Now, unlike that example, though, I knew what caused the problem immediately. And I really would not be surprised if you knew immediately what caused the problem here. But again, how do you know? I just want you to hold that thought. Because in this contrived example, we don't know. We are trying to find out, which means we need to debug. And when I need to debug, I still reach for console.log. I love console.log. I use it all the time. There is no shame in console.log. It is a quick and simple option to get more information and help you debug. And I'm going to use the debugger in later examples. I love the debugger too, but it's really a separate tool. And we use the tool for the job. That is just as true in debugging code as it is in writing code. And for this job, console.log is really just like perfect, okay? I just want to know a little bit more about what's happening in this function, right? I want to know, what is the value of the data when it's received? And what value is assigned to the config variable? And as I do this, I'm expecting the logs to happen in this order. So 1, 2, data, config. What I get, though, is 2, 1, config, undefined, and then I get the data, which is an empty object and expected. My config file has nothing in it right now. Now again, if you don't know why the order is off, that's totally okay. But this is where I would realize that this code isn't synchronous. If I didn't know before, I know now. And how do I know that? I've seen this before. I have found that most of the time, the answer to how do I know that really boils down to I have seen it before. I have worked with this before. And if you knew the answer, that is likely the answer that you also came up with. So if you have worked with Node, then you know that read file is asynchronous, okay? In the real version that this example is based on, when I called getConfig and I got undefined, that's how I knew it happened, right? I've worked with Node before, and I realized the function used read file, and that I had mistaken an asynchronous function for a synchronous one. Or maybe you've worked with asynchronous callbacks, and I say asynchronous because not all callbacks are, but that could have been the information that really clued you in here. Or maybe you didn't know until you saw this. This is a really big clue. And it's something that I've internalized through years of debugging. An unexpected order means code somewhere is asynchronous. And knowing this is really half the debugging battle, which is why debugging asynchronous code is tricky. You might not even know the code is asynchronous. You might write code like this, not knowing that read file is asynchronous, which, let's step through this so that we are all on the same page about what is actually happening here. First, the config file is created. Then we actually call read file, and since that's an asynchronous function, it starts, but it doesn't block the following line from executing. And that next line is actually returning the config variable, which was never set, and so its value is undefined. And meanwhile, read file actually receives the file, calls the callback where the data is assigned to the config variable, but it just doesn't matter because the outer function already returned in the previous step. Right? So that's how we get an undefined config even though the file is read, right? The data exists. But we're not waiting for the data, and that's the bug. And notice that at no point are we seeing an error message. Why would we? This code is incorrect, but valid, right? Bugs can be broken down into a few categories, and some are more difficult than others to debug. So, syntax errors. These are actually really quick fixes. Runtime errors, okay, maybe less quick to fix, but you do have errors that guide you in the process. But this, ooh, writing code that is valid but incorrect. This is the most difficult category to debug. Here's another example. Let's undo our past work on getConfig, and instead of attempting to return the config, we're actually going to wrap read file in a promise. And yes, like a quick note that there is a sync version of this, and in newer versions of Node, there are other things you can do. Let's pretend for this version, we can't do that. We are actually going to have to do the legwork ourselves of promisifying this, which is really not that much, okay? We're just going to return a new promise, and then we're going to resolve when we receive the data, okay? Really not that much work. And then we're going to run this, all right? We're going to see if we get what we want. We are going to call getConfig. We're going to attach a .then handler, which for now is just going to log the config to the console. And then when we run this the first time, we see undefined. Okay, here's the thing though, this example actually should work. The way that I wrote this code is correct. This should work. So let's log out the data and see what we get. Okay, the data is undefined. Okay, knowing this, I'm going to actually go check that the config file exists. And it does not, by the way. Turns out that when I undid my previous changes, I accidentally removed the config file too. This has happened to me before. It is very obnoxious, okay? But did we get an error? I don't know, let's log it and see if we got an error. Ooh, yes. We did, okay, no such file or directory. We did get an error. But I want to note that that's not the bug, okay? The missing config file is not the bug here. The bug here is the silent error. When I wrote that promise, I made a really classic mistake, okay? The promise resolves with the data, but it doesn't reject. So when read file can't find the file, it returns an error, but I don't know that. No one knows that. It has been silenced. And silent errors are the worst. Something has gone wrong and just no one knows about it. And these are super common in async JavaScript because, again, that code is valid. It works until there's an error. Now, knowing this, we're just going to fix our promise real quick so that the error surfaces. I'm going to need that reject function. And then I'm just going to use an if-else to decide when to resolve and when to reject. So if there's an error, we call reject with the error itself. Else, we're just going to resolve with the data. And now let's see if this works. Okay, we're going to call getConfig. Instead of a .then, this time we're going to use a .catch, which will catch the error, allowing us to log a more helpful error to the console. Let's run this. Okay, I didn't screw with you this time. It's not undefined. It actually works. So the promise is rejecting. We catch it. We log the error message. This looks good. So always reject. It is a best practice. Follow it. It will make debugging promises so much easier for you. But I should note that there are so many options for error handling to go wrong in asynchronous JavaScript. These bugs often fall into the category of valid but incorrect. Okay, let's look at another fun and infuriating example. Let's say we're building an application where a user can RSVP for an event. All right, that's what the RSVP function does. It also returns a promise, and it's handling errors with .catch. And our current task is to add some UI that shows a schedule of the user's various events. So let's add a .then that once the RSVP resolves, will update the UI. Now, this is and is not a good idea. We do need to do something like this. But written like this, we've created a bug. Now, unlike last time, I'm actually not going to reach for good old console.log. I still love it. But I think there's a better tool for the job, and that is the debugger. And I really love the debugger for async code because it helps offload the mental weight of thinking async. There is an extra mental tax when we write or debug async code. As humans, we are inclined toward events that happen one after another. So A, then B, then C. A, then B, then C, then B again. Doesn't really make sense to us, right? This is really kind of mind-bending. And with logging, you're actually still doing these mental gymnastics while also keeping track of what got logged when and where. And at some point, the mental tax is just too high. It is no longer effective. This is where the debugger can help you. Unlike logging, the debugger can pause execution. That allows you to inspect the state of an application at a certain point. And then from that point, you can step through your code line by line, running it as if it were synchronous. So we're going to take a look at this in the Chrome DevTools. I'm just going to show you some simple cases of using the Chrome DevTools. We're not going to go super in-depth with this. And I'm going to show you first the case where this code works, where you wouldn't notice that the bug is happening. So under the Sources tab, I have selected the file where the code runs, and I'm going to set a breakpoint on line 15, where the RSVP function is called. I've set the breakpoint. I'm going to click the button, which is going to run the code. It's going to hit that breakpoint and pause. And now I'm able to step over functions and run them line by line. And here you can see in the call stack area that I've hit the promise.then. As expected, we've hit the promise.then. Now I'm going to step into the promise.then. I'm just going to check that the event ID is the correct one. I can hover over that. I see 1, 2, 3. Yes, that is correct. And then I can just keep stepping through the program until it naturally executes. Great, we're done. So that's the case where this works. Here's the bug, all right? And to show you this bug, I'm going to break this code. I've modified the code so that the promise returned from the RSVP rejects. And so what I expect is that .catch is going to run, but .then is going to be ignored. We have the same breakpoint as before, same press of the button to pause the execution, same stepping through. Once again, in the call stack, you can see that we've hit the promise.catch, so that's expected. We did hit the .catch. Keep stepping through. Ooh, what's this? No, this is not supposed to happen. Okay, so we've actually hit the promise.then. You can see it in the call stack. So as this keeps going, what you're going to see is that the error message actually gets logged in the UI, but also the event gets added to the list. So this is not what we expected at all. So this is another example of valid but incorrect. And look, it is not unreasonable to think that since .catch is ignored when a promise resolves, that .then is also ignored when a promise rejects. And that actually is true. But what's also true is that the order matters. .thens after a .catch are still going to execute. So to fix this, we actually just need to move the .catch to the end. And now when the promise rejects, .then will be ignored. I show you this example because it's just one example of, I don't even know how many. I don't have time in this talk to talk about all the different options and intricacies of error handling in promises or async-await, because error handling is different in async-await. Async-await is like this really strange but lovely addition to JavaScript. It can make writing async code so much cleaner, so much clearer, but it also can introduce some issues. So here is some promise-based code, and let's say that we want to convert this to async-await. So when we do so, it might look like this, right? So we have an async function. We're awaiting promise 1 and 2. The problem is that the promise-based code and our async-await refactor are not equivalent. This actually might be fine. This actually might be OK, but we've taken code that did not block. Those two promises in the previous example ran in parallel, and we have modified it to block. Await blocks until the promise resolves or rejects. So this refactor might have some unintended consequences, and like might, we actually don't know. And this would be extremely hard to figure out. But promises and async-await, they have some really core differences, and this is really the biggest one. Promises are non-blocking. Async-await can be both blocking with await or non-blocking. Okay, await is not required in an async function. And also, async functions return promises. So this sort of intermingling of async versus sync code is why I call async-await strange. It is that same mental tax that I talked about earlier, thinking async, and it is a lot. It leads to something I call what does what and when and where, which means that you have to be familiar with all the ins and outs of different async structures in JavaScript. Promises, async-await, callbacks, set timeout. Keeping this all in your brain all of the time is impossible. Mistakes are bound to happen. Here's another favorite of mine. So I've written a tiny little application that fetches some posts and lists their titles, except I'm not seeing the data show up in the UI. First thing, I'm going to check the network tab, and I can see that the data actually is coming back, so something is wrong in my code. Let's set a breakpoint. And because I know the data is coming back, I'm going to pause the execution at line 12. I want to make sure this was set properly. Now, at this point, when I set the breakpoint, and I'm going to refresh so that the code gets hit and we hit the breakpoint, I'm going to see that results is undefined. And that's fine, because I haven't actually stepped over this function, which will actually run it. Now I step over the function, and I can see what results is. And yeah, I've done something kind of silly here. It's a promise. It's not supposed to be a promise. Async functions return promises. Sometimes when I am working with async-await, I actually get so used to the patterns inside of async-await where you can treat promises like they're synchronous that I just forget to switch into promise mode when I then call the async function. And this has happened to me numerous times. Really drives me up a wall. And so I'm going to fix this. I'm going to call fetch post, which returns a promise, and then I'm going to attach a .then handler, and that's where I'm going to set the posts, right? That's what I was supposed to do in the first place. And now this is going to work. But as I've said, I have made this mistake more than once. And not because I don't know that async functions return promises, but again, this is all a lot to keep in your head at once. The good news is that I am able to debug this relatively quickly. If I did not know what happened, if I hadn't had this experience before, it might be difficult to debug. Which brings me to the one debugging tool I haven't talked about yet, and it is the best one. And no, it is not TypeScript, it's not a linter, and it's not tests, even though those are all helpful and you should do those. Your best debugging tool is knowing something well. And knowing something well cannot come from memorizing the spec. Knowing something well is about experience. Going back to the start of this talk, the question of how do I know that? I said the answer to that is often experience. And I want to add on to that, because going a step further, that experience might have been, I have worked with Node and I know that read file is asynchronous. Or it might be, these logs are not in the expected order. And that first one, read file is async, that is just straight knowledge. Still really helpful for debugging. But that second one, how do you build up knowledge like that? That's not in the spec or the documentation. That is really hard-earned knowledge from seeing things go wrong. And as you go along in your career, as you debug, you will naturally start to build up this knowledge. But if you are struggling with a concept in particular, like debugging async JavaScript, I suggest be the bad dog. Okay, first, on a personal level, I believe all dogs are good dogs. Okay, I just want to note that. But this concept was introduced to me by a yoga instructor. Okay, she wanted to teach us how to do a certain pose properly, and to do that, she would teach us the pose with the correct alignment, and then she would ask us to be the bad dog, or in other words, to do the pose incorrectly with the incorrect alignment. Am I now perfect at yoga? No. But I do know what it feels like when the pose is off and I can adjust. And I get that same value when I apply this concept to code. Okay, I have struggled with async JavaScript before, and I realized that all the tutorials I was reading weren't helping because none of them were being the bad dog. I didn't know what it looked like when things went wrong. So if you're struggling or you want to know something really well, be the bad dog, learn all the ways it can go wrong and what those look like. You will still make mistakes. There will still be bugs, but it will be easier to fix those mistakes and to find those bugs. And isn't that what we all want? That was a lot. Thank you for listening and for being here.